Hi, welcome to StatStuff. I'm Matt Hansen. This lesson is part of an extended series on hypothesis testing in the analyze phase. In this lesson, I'll introduce you to the non-parametric types of tests that are used for testing non-normal data. This lesson doesn't have any critical prerequisites for the concepts that I'll discuss, but I still recommend that you review the other lessons on hypothesis testing if you already hadn't. But for now, let's review again the chart for finding the right statistical test to see where non-parametric tests will fall.
When we talk about non-parametric types of tests, it's usually when there's non-normal distributions or data that's non-normal. Well, in this case, what we're looking at is this section here, where we answered this question, is the data normal? And we said no, the data did not come back as normal after running a normality test. Well, if that's where we find ourselves, we'll find ourselves down this column, this path over here, depending on the type of data we're looking at. But these are the non-parametric types of tests.
Alright, now let's talk about what we mean by non-parametric tests.
Well, what are non-parametric tests? Well, they're statistical tests that don't require the distribution that we're looking at to have certain parameters, such as a normal distribution with parameters of mu and sigma, where mu is referring to the mean and sigma referring to the standard deviation. So since non-parametric tests don't require these parameters that are typical for normal distributions, then they can be a very powerful way of testing for non-normal distributions. So if non-normal distributions have bias, or so-called, then why is it that we should even test them? Well, for the most part, we would say that non-normal distributions may have some bias that might be skewed from the collected sample, but that may not always be the case. So it's more ideal if we can get our data to be normally distributed and run our statistical tests in that way, but it's not always possible. So first thing we need to ask ourselves is, should the process that's being measured have a normal distribution? If it should, then we should also ask ourselves, is the method used for collecting the sample data random and unbiased? And also, does the measurement extend across multiple and different processes? If we answer yes to either of the questions, then we need to go back and fix the method for collecting that sample and recollect it, so that way it would come out normal as we would have expected it. But if we answer no to that question, know that we wouldn't have expected it to be a normal distribution necessarily, then it may be appropriate to use the hypothesis testing that's used for non-parametric types of tests. So some measurements that don't extend below zero are more likely to be non-normally distributed. As an example, if we have measurements of time that start at zero, like a call duration in the call center or handle time that we're measuring, that doesn't go below zero, so the chances for that being non-normally distributed are much more likely. As well as measurements of dollars, where they start at zero, such as salaries or home values, where you can't really necessarily have it negative, well then those are more likely to be non-normally distributed.
Alright, before we close this lesson, let's discuss how we can apply some of these concepts in a practical way.
Well, I'd like you to refer to, again, those critical metrics you identified before, the output y as well as the input x's that we're using for the hypothesis testing. Now, for any of the continuous factors that you have that has a non-normal distribution, ask yourself, should the process that the metric is measuring, should it have had a normal distribution? If it should have, then ask yourself, is the method used for collecting the sample data random and unbiased? Or does the measurement extend across multiple different processes? If you answer yes to either of those, then try to go back and fix the method for how you collected that sample and try to recollect it. So that way you can see is it coming back as a normal distribution instead. But if it's not intended to necessarily be a normal distribution, then it could be appropriate for you to continue the hypothesis testing using the non-parametric types of tests.
Well, that wraps up this lesson. Check out StatStuff.com for many more resources that can help you achieve powerful results. I'm Matt Hansen. Thanks for watching.